Let us discuss about general organic chemistry. General organic chemistry. In short, it is also called as GOC. GOC. If we consider basic of any organic reaction, consider the substrate. Substrate, when it is made to react with suitable reagent in the presence of suitable solvent, gives intermediate, which is then gives respective product. Here, the property of the substrate is it may donate electron or it may accept electron. Here, the property of the substrate either to donate electron or to accept electron depends on certain effects. Depends on certain effects. We will see what are those effects are. First one is permanent effect. Permanent effect. In this permanent effect, what happens is electron displacement is due to the influence of atom or group present within the molecule. Present within the molecule. Okay. In permanent effect, electron displacement is due to the influence of the atom or group present within the molecule, and this causes permanent polarization of the bond. This causes permanent polarization of the bond. Example, first one is inductive effect. Inductive effect. Second one is resonance effect. Resonance effect. Third one is hyperconjugation. Hyperconjugation. Next type is temporary effect. Temporary effect. In temporary effect, electron displacement takes place in the presence of attacking reagent. In the presence of attacking reagent. Example, electromeric effect. Electromeric effect. Which is also called as polarizability effect. Polarizability effect. Let us discuss about inductive effect. First, we will consider CH3 is bonded to CH3. In this case, both the carbon atoms are of same electronegativity. Therefore, dipole moment mu is equal to 0 and the bond is non-polar in nature. Consider another example wherein CH3 is attached to CH2 is attached to Cl. In this case, electronegativity of Cl is greater than carbon. This Cl attracts share pair of electron towards itself and acquires partial negative charge. The first carbon acquires partial positive charge, which is called as delta 1 plus. When the electron density of first carbon atom decreases, it attracts the shared pair of electron from the second carbon atom. Therefore, second carbon atom also acquires a partial positive charge, which is called as delta 2 plus. Since there is electronegativity difference, dipole moment mu is not equal to 0. Therefore, bond is polar in nature. If we write the order of the partial charge of the first carbon atom, delta 1 plus, is greater than partial charge of the second carbon atom, that is delta 2 plus, because here the first carbon atom is directly attached to Cl. So in the second case, the bond between carbon and Cl induces the polarity. Let us define what is inductive effect. The phenomenon of displacement of sigma bonded electrons towards more electronegative atom or group, and the transmission of the effect throughout the chain. This is nothing but inductive effect. Let us discuss some important points of inductive effect. First one is inductive effect operate to sigma bond. Second one is partial charge development takes place. Partial charge is developed. Next one is inductive effect is distance dependent and can be neglected after third carbon atom. This inductive effect is weak and permanent, and this influences the physical and chemical properties of the compound. Inductive effects are of two types. First one is positive inductive effect and negative inductive effect. Let us discuss about positive inductive effect, which is also called as plus I effect. Consider open chain of carbon which is attached to electron releasing group. This is the first carbon atom, second carbon atom and third carbon atom. Here, this electron releasing group releases the electron towards the first carbon atom and acquires partial positive charge. This first carbon atom acquires partial negative charge, that is delta 1 minus. When the electron density of the first carbon atom increases, it distributes the electron density towards the second carbon atom so that the second carbon atom acquires partial negative charge. Second carbon atom acquires partial negative charge, that is nothing but delta 2 minus. When the electron density of the second carbon atom increases, the second carbon atom distributes the electron density towards third carbon atom so that the third carbon atom also acquires partial negative charge, which is delta 3 minus. So here, this electron releasing group is also called as plus I group and also called as electron donating group. Examples according to the power of inductive effect. Power of positive inductive effect. That is, first one is CH2 minus is greater than NH minus is greater than O minus is greater than C double bond O minus is greater than tertiary alkyl group, greater than secondary alkyl group, greater than primary alkyl group, and greater than methyl group. This order is because if we consider electronegativity order, carbon is less electronegative than nitrogen, nitrogen is less electronegative than oxygen. That's why carbon acts as a good donor. Coming to second type of example, that is tritium is greater than deuterium is greater than hydrogen, because with increase in the mass number, with increase in mass number, positive inductive effect increases. Let us discuss about negative inductive effect, which is also called as minus I effect. Consider open chain of carbon which is attached to electron withdrawing group. This is first carbon atom, second carbon atom, and third carbon atom. This electron withdrawing group withdraw the electron from the first carbon atom and acquires partial negative charge. This first carbon atom acquires partial positive charge, that is delta 1 plus. When the electron density of the first carbon atom decreases, it pulls the electron density from the second carbon atom, so that the second carbon also acquires partial positive charge, that is delta 2 plus. When the electron density of the second carbon atom decreases, again the second carbon atom pulls the electron density from the first carbon atom, so that the third carbon atom and also acquires partial positive charge, that is delta 3 plus. Here this electron withdrawing group is also called as negative inductive group and also called as electron seeking group. Let us see examples of negative inductive effect according to their power. That is NF3 plus is greater than NR3 plus is greater than SR2 plus is greater than NH3 plus is greater than NO2 is greater than SO3H is greater than Cn, which is greater than CHO, greater than COOH, greater than fluorine, greater than chlorine, greater than bromine, greater than iodine, greater than ether, which is greater than alcohol, which is greater than alkyne is greater than NH2 is greater than benzene is greater than alkene. You have to remember the order of inductive groups according to the power of inductive effect, which is very important to solve the questions. We will discuss about applications of inductive effect. First one is to compare acidic strength of aliphatic carboxylic acids. Consider an example. This is carboxylic acid, and here consider this as an aliphatic group. We will see what is that aliphatic group is. This carboxylic acid is a good proton donor and donates the proton and becomes like this: C double bond O, CO minus plus H plus. We should know that more the stability of conjugate base, more will be the acidic strength. Okay, so here this is the conjugate base. Here this negative charge indicates high electron density. That means this group is already high in electron density. If the positive inductive group is attached, that means electron donating group is attached, what happens? It releases the electron, which even more increases the electron density. And with increase in the electron density, it is going to destabilize the system. Destabilize the system. Okay. Therefore, we can say that positive inductive effect or electron donating group decreases the acidic strength. Okay. We will see one more example. Consider a carboxylic acid again, C double bond OOH. This is an aliphatic group. After donating the proton, it becomes C double bond O minus plus H plus. Here, this is the high electron density part. This is high electron density part. In order to stabilize this system, this electron density has to be reduced. So in order to reduce this electron density, we are going to attach negative inductive group. If the negative inductive group is attached, what happens? That means electron withdrawing group. It withdraws the electron towards itself and decreases the electron density. Decreases the electron density and increases the stability. Therefore, negative inductive effect or electron withdrawing group increases the acidic strength. So we can say that acidic strength is directly proportional to negative inductive effect and inversely proportional to positive inductive effect. Or you can also say that acidic strength is directly proportional to electron withdrawing group and inversely proportional to electron donating group. Let us discuss with some example. That is Cl CH2COOH, Cl2 CHCOOH, Cl3CCOOH. First, second, and third. You have to compare the acidic strength. What is the difference in these cases? There is a difference in number of negative inductive groups. In third one, we have 3 negative inductive groups. More the negative inductive group, more it withdraw the electron and more will be the stability. Therefore, third one is more acidic than second one and second one is more acidic than first. Before going to second application, you have to keep one thing in your mind, that is distance takes the first preference over the number, takes the preference over the power. Okay, this you have to keep in your mind. Whenever you find the inductive effect questions, you have to think of this. That is, first preference given to the at what distance number of inductive groups are present, and then the number of inductive groups are present, and then you have to give the power of inductive groups. In short, it can also be written as distance, next comes number, next comes power. This you have to keep in your mind. Okay, let us go for second application to compare acidic strength of alcohol. Second application to compare acidic strength of alcohols. Okay, let us take example, that is OH, Cl, and one more example is OH. Yeah. So we know that according to the power of inductive groups, We have an order. Fluorine is greater than, chlorine is greater than, bromine is greater than iodine. According to the power of inductive group, we have an order. Fluorine is greater than, chlorine is greater than, bromine is greater than iodine. So based on this order, because it is already discussed earlier, based on this, we will give the preference to the fluorine and we'll answer it as B is more acidic than A. But which is absolutely wrong. Because as I said now, the preference should be given to the distance, number and then power. Okay. So here this chlorine is at lesser distance to alcohol. In the case B, fluorine is at longer distance to alcohol and compared to A. Since we have to consider the distance of the inductive groups, A is more acidic than B. This is the correct answer. Next application is to compare stability of carbocation. Stability of carbocation. We know that this is the carbocation. How many electrons are present? One second. How many electrons are present? 1, 2, 3, 4, 5, 6. This is 6 electron system which is shortage of 2 electrons to follow or to obey octet rule. In order to obey the octet rule, it is 2 electron shortage. Therefore, it is considered as electron deficient. Carbocation is electron deficient because it is 6 electron system. Okay. Consider the carbocation. This is the carbocation. To this carbocation, if negative inductive groups are attached, what happens? Thus, all 3 negative inductive groups start withdrawing the electron from the carbon which is already electron deficient. Okay, what happens now? When all 3 negative inductive groups withdraw the electron from an electron deficient group, what happens? It leads to the destability of the system. Destability of the system. We will see now what if electron donating groups are attached. That means positive inductive groups are attached. Consider this is carbocation. To that, positive inductive groups are attached. What happens here? These positive inductive groups will donate the electrons towards the carbocation which is electron deficient and increases the stability. Here, all 3 positive inductive groups donates the electron towards the carbocation which is already electron deficient so that it increase the stability of the system. So we can conclude that negative inductive groups or electron withdrawing groups decreases the stability of carbocation and positive inductive group or electron donating group increases stability of carbocation. Consider the example. This is A and this is B. So the question is, among these two, which is more stable? We know that electron withdrawing group decreases the stability. In these two cases, which is the electron withdrawing group? Here NO2 is electron withdrawing group, or it is negative inductive group. This CH3 is electron donating group, and it is also called as positive inductive group. So which is more stable? B is more stable than A. So we can say that stability of carbocation is directly proportional to plus I effect and inversely proportional to minus I effect. This you have to remember. Okay, we will go to next application to compare the stability of carbanion. This is carbanion. How many electrons are there? 1, 2, 3, 4, 5, 6, 6 plus 2 electrons. This negative charge indicates the presence of 2 electrons. Therefore, it is 8 electron system. Since there is negative charge present here, it acts as good electron donor. Therefore, consider to the carbanion, what if positive inductive groups are attached? We will see. Positive inductive groups are attached. What happens? As we know that positive inductive groups are going to donate electrons. All three positive inductive groups are going to donate the electrons. Here, carbon has negative charge that indicates high electron density. So, to the high electron density species, all three positive inductive groups are donating electron, which further increases the electron density. Further increase in electron density decreases the stability. Okay, let us see what if negative inductive groups are attached to carbanion. Negative inductive groups. When negative inductive groups are attached to carbanion, what they do is these negative inductive groups are going to withdraw the electrons from the carbanion. So what happens? The high electron density is reduced. Here, this carbanion, that is nothing but it has high electron density. When the negative inductive groups are attached to carbanion, these are going to decrease the electron density and increases the stability. Therefore, stability of carbanion is directly proportional to negative inductive groups and inversely proportional to positive inductive groups or positive inductive effect. Or it is directly proportional to electron withdrawing group and inversely proportional to electron donating groups. Okay. We will see examples. Consider the previous example, that is H minus here and NO2 minus CH3. So we know that stability of carbon ion is directly proportional to negative inductive group. Which is the negative inductive group? Here NO2 is the negative inductive group and CH3 is positive inductive group. So this is A and this is B. NO2 is negative inductive group which is directly proportional to stability of the carbon ion. That means stability increases with negative inductive groups. So that therefore A is more stable than B. Next application is to compare the stability of free radicals. So this is free radical. How many electrons are there? 1, 2, 3, 4, 5, 6. 6 bonded electrons plus this is free electron. 1 free electron. 6 plus 1 is equal to 7 electron species. Shortage of 1 electron to obey octet rule. Therefore, it is electron deficient species. Electron deficient species. To this free radical, positive inductive groups are attached. What happens now? These positive inductive groups donate electron. All three positive inductive groups donate electron to the electron deficient carbon atom so that it increases the stability. Positive inductive groups donates electron and increases the stability. Therefore, stability of free radicals is directly proportional to positive inductive groups and inversely proportional to negative inductive groups. Or stability of free radical is directly proportional to electron donating groups and inversely proportional to electron withdrawing groups. So this you have to keep in your mind. Okay, let's see an example. So the question is, among these three, which is the most stable free radical? So we know that stability of free radical is directly proportional to positive inductive groups and inversely proportional to negative inductive groups. So in all these three cases, CH3 is positive inductive group, Cl is negative inductive group, Cn is negative inductive group. Therefore, C is the most stable free radical among these three. Okay, coming to next, we know the order of power of negative inductive group, that is Cn, then CHO, then COOH, then fluorine, chlorine, bromine and iodine. This is the order. So in this order, Cl is, when compared to Cn, Cl is less electron withdrawing group and Cn is the most electron withdrawing group. Since Cn is most electron withdrawing group, it will not donate any electrons to the carbon which is electron deficient, so that it will be least stable. And of course, when compared to Cn, Cl is less electron withdrawing group. There is a chance, there is a possibility of donating electrons to the electron deficient carbon, so that it comes second. So the order of stability is C is more stable than B is more stable than A. The next application is to compare basic strength of to compare basic strength of amines. So we all know that electron pair acceptor is acid and electron pair donor is a base. Electron pair donor is base. We have nitrogen which is attached to positive inductive groups and which has lone pair of electron. All these positive inductive groups donate the electron to the nitrogen. These three positive groups donates the electron to the nitrogen, so that the lone pair on the nitrogen is easily donated. That is, if availability of lone pair of electron on nitrogen increases, okay, if availability of lone pair of electron on nitrogen increases, nitrogen readily donates or nitrogen easily donates lone pair. If the nitrogen donates easily the lone pair, basic strength increases. Basic strength increases. Okay. Therefore, basic strength of amines, basic strength of amines is directly proportional to positive inductive groups and inversely proportional to negative inductive groups. Okay. In gas phase, order of basic strength is tertiary amines are more basic than secondary amines are more basic than primary amines are more basic than NH3. This is the order of basic strength in gas phase. Okay. We will see what is the order of basic strength in aqueous media. In aqueous media, okay, consider primary amines, that is or NH2. When made to react with H plus, the lone pair are donated to H plus and it becomes or NH3 or NH3. Since we are discussing the basic strength in aqueous medium, here there is a hydrogen bond formation takes place. How many hydrogen bonds are taking place? This is called as hydration. How many hydrogen bonds are there? 3 hydrogen bonds. How many positive inductive groups are there? Only 1 positive inductive group. Okay. Coming to secondary amines, that is R2NH, in the presence of H plus, lone pairs are being donated. Therefore, it becomes R2NH2. R2NH2. So again, formation of hydrogen bond takes place in aqueous media. OH2, OH2. How many hydrogen bonds are there? 2 hydrogen bonds. How many positive inductive groups? 1 and 2. Coming to tertiary amines, that is R3N in the presence of H plus, nitrogen donates the lone pair of electron and becomes R3NH. R3NH. So here in all three cases, nitrogen will be having positive charge because nitrogen has 4 bonded pairs. So here only one hydrogen bond can be seen, right? How many positive inductive groups are there? 1, 2, 3. Okay. If we talk about the basic strength, okay, we have to consider two conditions. That is, if R is equal to methyl group and if R is equal to ethyl group, what happens is, so coming to secondary amines, in both the cases, both in hydration and in positive inductive effect, it has 2 hydrogen bonds. Coming to positive inductive effect, it has 2 positive inductive groups. Therefore, secondary amines are more basic than tertiary and primary. Okay. Then, coming to primary amine, here we have 3 hydrogen bonds and 1 positive inductive group. So, in this case, here the hydrogen bonds takes the preference over the positive inductive effect. Therefore, next is primary amines and then comes tertiary. Okay. If R is equal to ethyl, what happens? Again, secondary amines takes the preference among all these three. Secondary is greater than. Coming to tertiary amines, here we have only 1 hydrogen bond and 3 inductive groups. Here, more the number of carbon atoms. More the number of carbon atoms, more will be the positive inductive effect. Okay, so in tertiary amines, if R is equal to ethyl, in tertiary amines, positive inductive group takes the preference over the hydration. Therefore, tertiary amines are more basic than primary amines. This is the order you have to remember when R is equal to methyl and when R is equal to ethyl. This is all about inductive effect and its applications. We will see resonance effect in next class. Thank you for watching.